During this session, I hope to introduce the idea of the greenhouse effect and how it's having an impact on the temperature of planet Earth, but also put it into a historical context, considering the evolution of the Earth's atmosphere. So let's think back to the beginning to start with. In the beginning, about 4,500 million years ago, Earth was formed. And when Earth was first formed, it had mainly hydrogen and helium gases in its atmosphere. This is a lot like the atmospheres of Saturn and Jupiter, but Earth was smaller and actually tended to lose a lot of these gases into space at quite an early stage. The early atmosphere was actually ended up being built up due to the intense volcanic activity. So the intense volcanic activity gave off a lot of gases, and there's lots of carbon dioxide, lots of methane, and lots of ammonia. Now, what these gases did was they worked a lot like Mars and Venus today. So they trapped heat, caused the atmosphere to get warmer and warmer and warmer. So the Earth's atmosphere also contained some water vapor, which as it cooled down formed the oceans. Now, carbon dioxide reacted with rocks and became trapped in them, so that's one of the reasons why the carbon dioxide levels dropped down. Then, about 3,000 million years ago, algae and plants started to colonize the Earth's surface, and that meant that carbon dioxide was taken in and oxygen started to increase. So the levels of oxygen increased. Photosynthesis meant carbon dioxide was replaced with oxygen. And over a long period of time, carbon dioxide became locked up in fossil fuels as well. So the carbon dioxide levels were being dropped and reduced. Nitrogen made an appearance later on. So as oxygen levels rose, the ammonia reacted with oxygen to form H2O and then pure nitrogen. Okay. What we find in today's atmosphere is that we've got 78% is actually nitrogen. There's also some organisms which such as denitrifying bacteria, and they broke down nitrogen compounds, releasing it into the air as well. That's something which you'll find out in the nitrogen cycle. And so what we have is a setup which has lasted fairly consistently for the last 200 million years. The majority is nitrogen, then we have about 21% of oxygen and 1% of other stuff. Now, that initial carbon dioxide, which helped increase the temperature of planet Earth in the first place, because carbon dioxide is a greenhouse gas, and we're going to talk about what that means in a moment. The levels of carbon dioxide were actually quite small. They are part of that other. And what happened is there was a carbon dioxide cycle, and this went through round and round and round. Photosynthesis absorbed carbon dioxide, releasing oxygen. Plants would die and decay, and they might release carbon dioxide back in the atmosphere, but there was kind of a closed system. Up until the point when man came along and started introducing additional carbon dioxide emissions ever since the Industrial Revolution. Now this has caused a change, and this is a change of consideration which we're going to be thinking about in a little bit more detail later on. So initially carbon dioxide levels were maintained at quite a low level. So what does this all mean? I've mentioned it a few times about the greenhouse effect. Okay, so the greenhouse effect works like this. If there's carbon dioxide in the Earth's atmosphere, what it does is it allows heat and light energy to reach us from the sun, because it happens to not interact with infrared light at those specific wavelengths released by the sun. But then what it does is the heat which is reflected off the Earth's surface, or given off by the Earth's surface as a hot object, is at slightly different wavelengths. And what it does there is that some of the heat escapes back into the space, but some of it's reflected back down to Earth and captured. And this is known as the greenhouse effect. It's known as that because if you look at greenhouses, you may think, how does a glass outside, or a glass layer in a greenhouse, allow greenhouses to get so warm? It's because exactly the same process takes place. So it's helping capture heat and allow the Earth's temperature to increase, which was very, very useful to start with. So let's look specifically at some of these 1% of gases. Carbon dioxide I've mentioned. There's a bunch of other atmospheric gases, nitrogen and oxygen, which I've already mentioned, gases such as argon. Now, none of these absorb infrared. So that means they don't have any impact in either stopping the sun's light coming in or stopping the radiation which is reflected back from planet Earth. However, water and carbon dioxide do. So these become known as greenhouse gases because they can absorb specific types of infrared wavelength, allowing it to be trapped by the Earth's atmosphere. So let's go through some key points about greenhouse gases. I've just made them as bullet points here. So atmospheric gases and radiation. Number one, carbon dioxide nor water vapor, neither of them absorb high frequency radiation arriving from the sun directly. So they don't absorb or stop sunlight getting in, but what they do absorb is the lower frequency infrared radiation that's emitted by planet Earth. Okay, so sunlight still comes in, they just don't allow the radiation emitted by planet Earth to escape. Now, this is the reason why the Earth's atmosphere gets warmer, because that energy is prevented from leaving, so that means there's not a perfect balance between energy coming in and energy going out again. And we've seen that in some earlier models. So this is known as the greenhouse effect. And we've got to remember that the greenhouse effect was initially really, really important for the evolution of the planet Earth as an entity itself, because it meant that planet Earth could get much warmer and reach the ideal temperatures of supporting life which it has now. Other gases in the atmosphere do not absorb infrared, so there are other gases up there, but there's only certain greenhouse gases, carbon dioxide and water being crucial, but there are some others, it has to be said. So that wraps up the idea of planet Earth's atmosphere evolving over a long period of time, getting to a point where everything was balanced out, and this greenhouse effect was the effect of capturing some of the heat which was being reflected by the planet Earth and sent back again, causing the planet to get warmer and warmer. This was useful at some stages, but over the last 200 years the levels of carbon dioxide have been shifted by our influence, and therefore now man has a major impact in increasing